And now we are discussing about the GATE 2014 paper, and that too held on 15th February and morning session. So the question is, ideal current buffer is having low input impedance and high output impedance, high input impedance, high output impedance, high input impedance, low output impedance, low input impedance, low output impedance. And ideal current buffer is nothing but simply it is going to be current buffer is simply you can think it as current amplifier, which takes what it is taking is nothing but it is taking current amplifier or current buffer that takes input as current and that gives output is also as current I naught. So whatever the current you are going to give, let us assume this is II. Every current source will be having some internal resistance which will be in parallel with that one. So this is going to be treated as RS and it is IS. For example, IS is the current source that you are going to be applying and RS is the internal resistance that you are going to be connecting it to the current buffer. Current buffer characteristics are going to be like this. So current buffer is going to be consisting of one internal resistance that is nothing but Ri, and next a current source, dependent current source, which depends on this is AI times of II. II is nothing but current entering into Ri, that is II, and this will be having it is a current source. Again remember that one, it is a current source and this current source is going to be having some internal resistance that is R0 and it will be connected to load RL. So current buffer implies nothing but the current I0 that has to be making I0 is equal to IS. So you must make I0 is equal to IS, that is nothing but ideal current buffer. Whatever the input current you are applying to a load, that has to be same as the output current must be same as input current, that is ideal current buffer. So what conditions will make this condition true? So we know that one using current division rule, more current flows into the lower resistance side. So if you want to make total input current has to be same as source current, at that time RS has to be very large or Ri is going to be very small. We cannot assume the condition based on RS because RS is going to be related to the source. The source can be anything, it can have any source resistance. What we are dealing is nothing but ideal current buffer. So we must make a condition with respect to input impedance. So Ri must be very small compared to RS. So that is nothing but low Ri it requires. If it is low Ri, ideally Ri has to be 0, ideal value. So if it is 0, at that time total IS will be equal to, then you can say that one II is equal to IS. Next, that current is going to be multiplied by the current gain AI times and you are going to be getting a current source over here. This is the current source AI into II. If you want to get the same amount of current whatever you are getting into the RL is nothing but you cannot say condition depending on the RL because load can be anything, load varies also. So again you are going for the condition based on R0. If R0 is going to be very large compared to RL, at that time entire current generated is going to the load. So the value of R0 is going to be high. High R0 is required. Ideally R0 is going to be infinite. If this condition satisfies, at that time I0 is equal to AI times of II, that is nothing but AI times of IS. Current buffer is nothing but AI is equal to 1, so 1 into IS, which is nothing but I0 is equal to IS. This is what current buffer. So the required conditions for the current buffer is nothing but low input impedance and high output impedance. Low input impedance and high output impedance is nothing but the answer is A. So ideal current buffer should have low input impedance and high output impedance. Thank you.